Welcome back. This is an Aleks study video on dilution. When you dilute something, you put more water in it and make it less concentrated. So you dilute frozen orange juice to a bigger volume, but it's less concentrated because it's more water, more filler. So what you have to remember in terms of concentration, there's various ways to do concentration. What we've been working with is molarity. And molarity is based in moles, that's why it's molarity. It's going to be number of moles of solute, which is what you're dissolving, over liters of solution. Okay, whatever your final solution is in liters. If I were to say just add water, let's say I make some Kool-Aid and it has a certain amount of Kool-Aid in it and a certain amount of water in it, and it's too strong, so I make it more dilute by adding water. I haven't changed the amount of Kool-Aid that's in it. I've only changed the amount of water that's in it. So the moles of Kool-Aid is still the same. If I add water, I haven't changed the moles of solute. So for instance, if I solve for the moles of solute by getting rid of the liters, liters is being divided by, so if I multiply molarity by liters, I've solved for the moles of solute. The moles of solute is going to be the same in the new solution, right? I add water, I increase its volume, I change its volume, but I haven't changed its moles any. So if I solve for moles and then find out what the new molarity is, then the new molarity is the same amount of moles divided by the new volume. And if I'm trying to find a new volume, I can use the same amount of moles that I had because it hasn't changed. All I've done is change the water by making it more dilute. So what I'm going to do, my strategy for here is solving for moles here. So let's see what it asks for. A chemist must dilute 18.4 mils of 758 millimolar aqueous iron bromide solution until the concentration falls to 16 millimolar. Okay. He'll do this by adding distilled water to the solution until it reaches a certain volume. What's the new volume? So right now I've got a millimolarity that they're going to give me. So I can solve for millimoles, but the millimoles is going to be the same for the new concentration. So let's fill in what we know. We know that the molarity or the millimolarity here, millimolarity is 758 millimolar, and I'm going to solve for millimoles. And how many liters of solution is that? We're starting with 18.4 milliliters, and remember I have to put that in liters because this only works in liters. So milliliters to liters, I divide by 1,000. 1, 2, 3. So I have 0.0184. Okay, that would be liters. So if I take these two numbers and multiply it, I've solved for the number of millimoles in this original solution. Okay, so let's see what that's going to be. I have 758 times 0.0184, and I have millimoles equals 13.9472. All right, so that's going to be the same moles in my new one. Now they're going to give me a concentration. So here's the new concentration. It's going to be 16.0 millimoles, which is going to be millimoles over liters. My millimoles are the same because I haven't changed it. I've just changed the water. So I'm at 13.9472 over liters. You see, so I have everything I need. I'm just solving for liters. So I'm going to bring this up and divide by the 16. So I'm going to have 13.942. Do you see? If I bring this up, it'll be 16 point this liters, and then divide by the 16, get it out of the way. And I'm going to have 13.9472 divided by 16. This is now liters, so I have 0.8717 liters of new stuff. All right, so let's see how many significant digits we're talking about. I was given 3, I was given 3, I was given 3. So I want to round this to 3. So it's going to be 0.872 liters, 0.872 liters of the new volume. Okay. So this is actually quite simple. I think you'll do fine.